Have you ever found yourself just sitting at my desk, staring at the clock, and feeling like a human switchboard?
Oh, yeah. Like, the tension is just palpable.
Right. You probably know the exact scenario we're talking about. It's launch day. You have, 3 different monitor screens glowing in your face.
And none of them have good news.
Exactly. One has your CI/CD pipeline, which is currently this uh, terrifying shade of yellow as you wait for it to finally turn green.
Yeah, that yellow loading spinner is just, it's the stuff of nightmares.
It really is. And then, another screen has your Datadog dashboards tracking CPU spikes, latency, all of that. And the third is just this endless scrolling waterfall of Slack pings from the product team asking, like, is it live yet? Are we live? What's the status?
Yes, the constant checking in.
And you are just frantically trying to time everything perfectly under this immense pressure.
Yeah.
Because you know that if you execute one command, like a minute too late, or if a database migration locks a table for just a few seconds too long,
The whole fragile ecosystem just comes tumbling down. Right.
total disaster.
It is a distinctly modern kind of operational anxiety,
Yeah.
You are essentially acting as the single point of failure in a highly distributed, incredibly complex system.
Which is terrifying.
It is, because you are expected to orchestrate this flawlessly timed symphony of moving parts, often with thousands or, even millions of concurrent users actively hitting your infrastructure.
While you're trying to rewire it in real time.
Exactly. You're changing the tires on a car while it's driving down the highway at 80 miles an hour.
And that highly relatable, highly stressful scenario is exactly the pain point we are tackling in today's deep dive. We are extracting the core insights from a really brilliant piece of source material today. It's a blog post from tech-reader.blog, written by a software engineer and technology writer named Aaron Rose, and it's titled The Secret Life of AWS, the Master Switch.
It's a great piece, really insightful.
It is. But what makes this piece stand out isn't just the technical architecture it proposes, but the narrative framework the author uses to dissect it. He places the discussion not in a sterile open plan tech office, but in a grand Victorian library in London.
Which is just such a jarring contrast, right?
Right. We are introduced to Margaret, this seasoned Zen-like senior engineer who values craftsmanship above all else, and her junior colleague, Timothy, who is currently living the exact launch day nightmare we just described.
The setting is just a really clever device. By placing the bleeding edge of modern serverless cloud architecture in a room filled with leather-bound books and quiet contemplation, the author highlights the ultimate goal of DevOps.
Which is what, exactly?
Creating a state of psychological and operational safety. Because outside those library walls, the digital world is a chaotic mess of broken pipelines, furious customers, all that. But inside, architecture is treated with deliberate precision.
I love that. Deliberate precision. And that brings us to our mission for this deep dive. If you are managing a serverless stack, or really any modern application architecture right now, you know the human switchboard routine just isn't sustainable.
It burns people out quickly.
Yeah, exactly. So our goal today is to extract the core DevOps philosophy from Margaret and Timothy's story. We are going to look at how adopting AWS AppConfig and feature flags can fundamentally rewrite your relationship with launch day, taking you from a state of pure panic to total programmatic control.
Yeah, and to understand the solution, we first need to look really closely at the specific crisis Timothy is facing in the story.
Right. Lay it out for us.
So the author frames this as episode 75 of Timothy's tech journey. So, he is not a novice. He's been around the block.
He's seen some things.
Right. He has survived chaos engineering. He has built multi-region failovers. But right now, he is staring defeatedly at a mandate from the marketing department.
Ah, the classic marketing mandate. What do they want?
They want a massive new AI recommendation engine launched next Tuesday at exactly 9:20 a.m. for their premium users.
Okay, specific.
Very. Then they want it rolled out on Thursday at noon for everyone else. And critically, if customer support gets overwhelmed by the new feature, they want an emergency rollback option ready to execute instantly.
Instantly. No pressure, Timothy.
Not at all. Right.
So Timothy is dreading it, obviously, because he is mapping those business requirements directly onto his deployment pipeline. He knows he's going to be sitting there at 8:55 a.m., his stomach in absolute knots, pushing code, waiting on Canary deployments to shift traffic, and just hoping the compute layer stabilizes by 9:00 a.m. sharp.
Yeah, and then he has to do it all over again on Thursday.
Right. It's just a recipe for an ulcer.
What's fascinating here is how Margaret, the senior engineer, diagnoses his panic. She doesn't offer him a faster CI/CD tool or, a better rollback script.
Which is what you'd expect, right? Like,
Right.
oh, here's a new tool to make this faster.
Exactly. Instead, she points out a fundamental flaw in his mental model. She tells him that he is conflating two entirely distinct concepts. He is confusing the act of deploying code with the act of releasing a feature.
Okay, let's unpack this because this feels like the absolute crux of the entire philosophy. Deploying code versus releasing a feature.
They are not the same thing at all.
So Margaret is arguing that deploying code is purely a technical event, right? It's moving binaries or scripts onto a server. Releasing a feature, on the other hand, is a business event, the moment the end user actually gets to interact with the new capability. And she insists that they should never, ever happen simultaneously.
Never.
If we think about this in terms of like a stage play, deploying the code is building the elaborate sets, setting up the lighting rigs, getting all the props in place. That is the technical work, and you do it behind a heavy closed velvet curtain.
Yeah, the audience doesn't see any of that.
Right, and then releasing the feature is the moment you actually raise that curtain for the audience. But, I mean, if I look back at the last decade of software development, the Big Bang release, where we push the code and cross our fingers right at the exact moment we want the feature live, that has been the industry standard.
Oh, absolutely. It's the only way we knew how to do it.
So why did we accept that for so long if it's so inherently stressful and risky?
Well, we accepted it because historically, our infrastructure was incredibly rigid. When you had monolithic applications running on, bare metal servers, changing the behavior of the application fundamentally required replacing the application itself.
Oh, I see. You couldn't just tweak it on the fly.
No, you had to physically alter the state of the machine. You had to bring down the old version and spin up the new one. But as we shifted toward microservices and serverless architectures, the logical separation became possible, even if our mental models sort of lagged behind.
Like the tech evolved faster than our habits.
Exactly. I mean, imagine the stress of building that theatrical set you mentioned while the audience is already filing into their seats and watching you.
That sounds like a stress stream.
It is. But that is what a historically standard deployment feels like. By separating the technical deployment from the business release, engineering teams basically reclaim their schedules.
So Timothy could deploy that complex AI code on, like, a quiet Wednesday afternoon.
Yes, when network traffic is low, when he is well-rested, when he's had his coffee, the product teams still get to orchestrate their dramatic 9.0 a.m. Tuesday release, but the technical risk has already been neutralized days in advance.
So it's a massive paradigm shift. You completely separate the construction of the project from the reveal of the project. But if we follow that logic, we run into an immediate structural problem, right? If we are building the stage early, behind a closed curtain, how do we mathematically ensure the audience doesn't accidentally see the construction? Like, if Timothy deploys his AI recommendation code into the live production environment a full week early, how does he ensure no user traffic actually hits it?
Right. You don't want a user stumbling into a half-built feature. That is where Margaret introduces the mechanism of dark launching.
Dark launching sounds very stealthy.
It is, yeah. And it's enabled by the use of feature flags, which you might also hear called feature toggles. Margaret instructs Timothy to push his code today, but it will sit in production completely dormant.
Here's where it gets really interesting, because if you are listening to this and you've spent any time in a modern code base, you understand the basic mechanics of conditional logic.
The good old if-then statement.
Exactly. A feature flag, at its core, is really just a conditional execution path. We can think of it like a railway switch track. You can spend weeks or even months building this massive new spur line off your main railway. The physical tracks are there, the gravel is laid, the signals are up.
The infrastructure exists in the real world.
Right. But until you physically flip the switch on the main line, the trains just keep rolling straight past it on the legacy track. They never even touch the new infrastructure.
It's completely bypassed.
Yeah. So in the code base, if the flag, let's call it enable error recommendations, if that evaluates to false, the system entirely ignores the newly deployed AI functions and safely routes all execution through the legacy engine.
This raises an important question, one regarding the concept of the blast radius.
Oh, that's a good point.
Right. Because a common anxiety for engineers who are just adopting dark launching is the fear of introducing dormant, untested material into a live ecosystem.
Like, I put this code in, what if it accidentally breaks the legacy system just by being there?
Exactly. It's a totally valid fear. But the beauty of a properly implemented feature flag is the strict logical isolation it provides at the compiler and runtime levels.
So it's walled off.
Yes. logically walled off.
Yeah.
Because the new execution path is wrapped entirely inside that conditional statement, and the condition evaluates to false, the runtime environment simply skips over the new memory allocations and logic branches entirely.
It doesn't even know it's there.
Right. This isolation is what removes the massive risk of that big bang release. The code exists in the live environment. It can even be tested internally, by routing specific test user IDs down the new track, but it does not impact a single public end user.
That makes perfect sense. But to push the railway analogy just a bit further, if you keep building new tracks and leaving the old ones behind, eventually you have a logistical nightmare on your hands.
Oh, definitely.
Like, what happens if an engineering team just keeps wrapping new code and feature flags and never cleans up the old ones?
Yeah.
You'd end up with a code base that is essentially a maze of dead ends and abandoned switch tracks.
Yeah. You are identifying a very real phenomenon known in the industry as flag rot, or feature flag technical debt.
Flag rot. Yikes.
It's an ugly term for an ugly problem. It is a critical operational hazard. If you leave hundreds of dormant flags in your system, not only does your code base become incredibly difficult to read and maintain, but you also increase the risk of an old, incompatible flag being accidentally toggled back on months later.
Oh, wow. Which could cause, catastrophic data corruption.
Absolutely. So feature flags require strict lifecycle management. Once a feature is fully released, stable, and running at 100% capacity, the engineering team must go back in, strip out the conditional flag logic, and permanently hard-code the new path.
So the flag is a temporary bridge, not a permanent structural pillar.
Exactly. You have to take the scaffolding down once the building is finished.
Right. Okay, so assuming Timothy is practicing good lifecycle management, we have the tracks built, and the train is safely avoiding the new AI engine. We have successfully decoupled the deployment from the release.
Which is a huge win.
Massive win. Timothy deployed the code. He slept great over the weekend. His Datadog monitors are all beautifully green. But that brings us to the actual operational reality of launch day. We have the dormant code sitting behind our logical switch track. Who gets to flip that switch, and how do we execute that state change across thousands of concurrent Lambda functions without triggering a massive CPU spike or, DDoSing our own database?
Right, because a sudden state change can be chaotic if not handled right.
No.
This is the exact moment Margaret introduces the core architectural tool, AWS AppConfig. This is the master switch in our scenario.
Now, if you are working within the AWS ecosystem, you know there are multiple ways to store configuration data. A very common one a lot of people use, is AWS Systems Manager Parameter Store.
Yes, very popular.
That's a great tool. So why wouldn't Timothy just use that to hold the Boolean value for his feature flag?
Well, if we connect this to the bigger picture, we have to analyze what these specific managed services are uniquely optimized to do.
Okay, break that down for us.
So Parameter Store is fantastic for static infrastructure data and secrets. Things like database connection strings, API keys, or environment variables.
Okay.
These are values that are read at startup and rarely change during the lifecycle of an application instance.
They're set in stone, mostly.
Right. But AWS AppConfig is purpose-built from the ground up for managing dynamic runtime behavior. It is designed for configurations that need to change frequently and rapidly while the application is actively serving traffic.
So it's built for speed and flexibility.
Exactly. And it propagates those changes without requiring a system restart or a completely new deployment pipeline.
So it's kind of the difference between the blueprint of a house and the thermostat of a house.
I like that analogy.
Right, because the blueprint is static. You reference it when you build the walls. That's parameter store. But the thermostat is dynamic. You change it on the fly to alter the environment without having to tear down the drywall. And that's AppConfig.
That's a perfect way to look at it.
But let's get into the weeds on the mechanics of how that thermostat actually talks to the application. Because if you have millions of users hitting a serverless application, that translates to millions of Lambda function invocations. If every single one of those invocations makes an API call to AppConfig to ask, hey, is the flag true or false? Wouldn't the network latency just skyrocket? You would throttle your own AWS account instantly.
Precisely. You would basically create a self-inflicted denial of service attack.
Right, which we want to avoid.
Very much so.
Right.
So this is where Margaret walks Timothy through AppConfig's highly optimized polling mechanism, which is specifically tailored for ephemeral compute environments like AWS Lambda.
How does it work?
Well, AppConfig doesn't require the application to download the entire configuration payload on every single request. Instead, it utilizes an extension that runs as a sidecar process within the Lambda execution environment.
Oh, a sidecar, so it's running right alongside it.
Yes, and it caches the configuration locally. So when the function runs, it just checks that local cache, taking mere milliseconds.
Super fast.
Exactly.
Okay.
Meanwhile, the sidecar process is communicating with the AppConfig control plane using something called a config token. It essentially utilizes long polling to ask, here is the cryptographic token representing my current state. Has the configuration mutated since this token was generated?
So AppConfig essentially acts as a highly intelligent, lightweight gatekeeper at the edge.
Yes,
If
exactly.
the configuration hasn't changed, the AppConfig control plane doesn't send the data back over the wire. It just returns a tiny response saying the state is unmodified, and the Lambda function continues using its local cache.
Right. It saves so much bandwidth.
It only pulls down a new JSON payload when an actual mutation has occurred. That solves the scaling issue beautifully, doesn't it? It minimizes compute overhead and network bandwidth.
It's incredibly elegant.
So let's take this architecture and apply it to the business handoff we talked about earlier. Let's look at next Tuesday morning. It is 8:59 a.m. The marketing deadline is 60 seconds away. Where's Timothy?
Timothy is completely removed from the critical path.
Yeah.
He is likely drinking his coffee, maybe moving on to his next sprint task.
Just totally relaxed. At 8:59 a.m., the marketing manager, the person who actually owns the business release logs into the AWS AppConfig console, they navigate to the feature flag tied to the AI recommendation engine, and they execute a state change, flipping the flag from false to true.
Yes. And within seconds, that state change propagates through the AppConfig control plane.
Just like that.
Just like that. The next time those Lambda sidecar processes poll with their config tokens, the control plane recognizes the mutation and pushes down the new tiny JSON payload. The local caches are updated. The very next time user traffic hits the application, the if statement evaluates to true, the execution path shifts, and the AI engine is live.
No CI/CD pipelines churning away.
Nope.
No canary deployments shifting traffic percentages at the load balancer level. No container image rebuilds.
None of it.
The underlying compute infrastructure didn't even blink. Only the localized runtime configuration changed.
It's seamless.
But I have to bring up a significant point of cultural friction here.
Oh yeah, let's hear it.
Because while this sounds architecturally elegant, giving the marketing department direct access to production configuration state is going to induce panic in a lot of engineering teams.
Oh, engineers are going to hate that idea initially.
Right. Engineers are the ones who carry the pagers. If a non-technical user accidentally uploads a malformed configuration file or, like, typos a critical value, they could bring down the entire application. How do engineering teams establish the organizational trust required to hand over that master switch?
That cultural anxiety is entirely valid. And it is a massive hurdle in DevOps transformations. You cannot solve a human trust problem with just a UI dashboard.
No, you definitely can't.
This is why AppConfig implements rigorous pre-flight JSON schema validation.
Oh, validation. Okay.
Right. The engineering team doesn't just hand over a blank text box to marketing. They define a strict mathematical and syntactic contract.
Like guardrails.
Exactly like guardrails. The schema defines exactly what data types are allowed, what fields are required, and what the constraints are. If the flag requires a Boolean and the marketing manager accidentally inputs the string true, like spelled out as a word, or just entirely omits the field, AppConfig's control plane intercepts that request.
Before it breaks anything.
Yes. It validates the proposed state against the schema before it is ever allowed to propagate to the data plane.
Ah, so it mathematically enforces safety at the edge.
Precisely.
The system simply rejects the malformed payload, throws an error in the console for the marketing manager, like, hey, fix this, and the live application continues running perfectly on the last known good configuration.
The bad data never even reaches the runtime environment.
That validation contract is what builds the trust between the departments.
Exactly. And it perfectly addresses the third requirement from Timothy's marketing team, the emergency rollback.
Oh, right. They wanted an instant rollback option.
Right. Under a legacy pipeline, rolling back a deployed artifact takes time. You have to locate the previous stable build, initiate a reverse deployment, wait for containers to spin up. It's a process.
And while you're doing that, users are getting errors.
Exactly. But with AppConfig, if customer support is overwhelmed at 10:00 a.m., the marketing manager logs back in and changes the flag back to false. The caches update instantly. The execution path reverts to the legacy track. The crisis is averted in milliseconds, and the on-call engineer's pager never even rings.
Wow. It also gives them granular control for that staged rollout, doesn't it? Marketing wanted premium users first on Tuesday, then everyone else on Thursday.
Yes, that's another powerful feature.
With AppConfig, you aren't just flipping a global binary switch. You can implement targeting rules based on user attributes. You can evaluate the JSON payload to say if the user session token indicates a premium tier, evaluate flag to true. If not, evaluate to false.
Exactly. The marketing team can test the waters natively without requiring Timothy to write complex, bespoke routing logic in the core application code.
It really allows the technical builders to focus on architectural craftsmanship without the artificial pressure of a ticking marketing clock.
Yes.
And simultaneously, it grants the business leaders immediate autonomous control over the user experience. It creates this highly resilient division of labor.
It really is the best of both worlds.
So what does this all mean? Let's synthesize this for you as you look at your own architecture and workflows. We started with Timothy's launch day panic, the sweat, the fragile pipelines, the human switchboard reality.
The nightmare?
The nightmare, yeah.
Yeah.
And we ended up in a scenario where deployments are decoupled, blast radii are logically isolated, and business state is managed dynamically at runtime.
It's a complete transformation.
It is. And the lesson here extends beyond just AWS AppConfig or serverless patterns. Whether you are migrating a legacy monolith or orchestrating a massive product launch, the core philosophy holds true. Separating the physical construction of your systems from the business reveal of your features is how you engineer operational resilience.
You build the infrastructure securely, you wrap it in logical controls, and you turn your application state into something dynamically programmable.
You are no longer just surviving your deployment windows, you are actively architecting psychological safety into your engineering culture.
Which is just as important as the code itself.
Absolutely. And that leaves me with one final provocative thought for you to ponder.
Lay it on us.
If we have evolved to a point where application state is just a tiny JSON payload evaluated in milliseconds and protected by schema validation,
Right.
how long until we don't even need the marketing manager to click the button?
Oh, wow. Okay.
If a feature flag can be toggled via an API call, what happens when we wire those APIs directly into our observability platforms? Could a system automatically monitor its own Datadog metrics, track its own server load, or watch PagerDuty incident volume, and dynamically flip its own feature flags in response to stress?
The system healing itself.
Exactly. Could we see a future where the architecture becomes entirely self-regulating, stripping human latency out of the release and rollback equation completely? It is a fascinating horizon to ponder as you evaluate your own infrastructure today.
The transition from human-operated switches to autonomous self-healing systems is undoubtedly the next frontier of this architectural evolution.
It's going to be wild to see. Thank you for joining us on this journey from frantic deployment pipelines to the quiet, dynamically controlled efficiency of modern cloud architecture. We will see you next time.